all. So today we are going to see the revision of unit number 5. Now unit number 5 is basically kinematics. So we are only going to see the variables of motion, that is S, U, A, V and T. Based on that only we are having some motions of the particle. First motion is rectilinear, then curvilinear, then projectile. So in like rectilinear motion, particular rectilinear motion is divided into four types. Rather, first one is motion under uniform velocity. We are calling it as a uniform motion. The particular formula we are using here is a very constant formula, that is v is always constant here and v is equal to x upon t. Therefore, if we rearrange the terms, we can get these formulas. Only based on these formulas, this first type will be there. Now, second type is what? Uniform acceleration motion, means acceleration will be constant. Then Newton's laws of motion are applicable here. What are those? V is equal to u plus at, s is equal to u2 plus 1 half at square, and v square is equal to u square plus twice s. So based on that, we can have the problems. And what to particularly see in the problem, that if given is in the problem is let's say s, then a and t, and they are asked for u, so you should have this formula number 2 to use. Likewise, we will see in the problems also. Then third type is motion under gravity. So this is again same. Here, just the acceleration constant is gravity, and it is having the value of 9.81 meter per second square. Then, if upward motion of the particle is considered, that is motion against gravity, then A should be taken at minus g. So your formula will become like this, three formulas. Samely, if the downward motion of the particle is there, then A should be taken as positive g. And these three formulas that we will get. You have to see in the problems, all the terms will be given either if with the formula contains four terms here. So any three terms will be given. Otherwise, you can use two formulas to get the equations, and remaining two terms we can get using solving those equations. So that will be the case. The last type from the rectilinear motion is motion under variable acceleration. Now A changes. A always changing. So particularly the formulas which are applicable here are these, and we have to use integration as well as differentiation. So one step up, step down. When we are going to see a step up, we have to use integration. When step down, we have to use differentiation. Step up, step down means acceleration is given, you have to find out the particular velocity. Then we can use your step down, that is integration. And if velocity is given and you have to use acceleration, then we have to use particular differentiation there. So these particular are there in rectilinear motion. Now the second part is curvilinear motion. Curvilinear motion is divided into three types, that is rectangular components or Cartesian coordinates. Basically those are coordinates of velocity and acceleration. So Vx we have to find out, Vy we have to find out, Ax we have to find out, Ay we have to find out, and using that we have to use this formula for finding out the magnitude as well as direction of velocity, acceleration, and particular their directions also. Now second type is important, that is normal and tangential coordinates or path coordinates we are calling it as. Here velocity will be tangential to the path, therefore velocity will be tangential velocity only. There will be no velocity in normal direction. Directly your tangential acceleration will be v by t, and your normal acceleration is equal to v square upon rho. This is based upon that particular, what we are saying it as a your which force we are calling it as particular your that mv square upon r, that we are calling it as the force which is in the opposite direction to the motion. If you are particular on the track on the curve path, then one force will be acting always towards the center of that curve path, and that force is nothing but mv square upon r. So we are calling it as a centripetal force. So that centripetal force should be taken into consideration here, and this formula is getting into formation. Now last is a radial and transverse. It is called as a polar coordinates. So basic formulas are there, like Vr is equal to r dot, which what is r dot? R dot is nothing but dr by dt. What r double dot d2r by dt square. Samely with the theta. And these are the formulas you have to remember. And these formulas will be solving the problems based on the radial and transverse coordinates. So this is the second part of fifth unit. Last part is projectile motion. So in projectile motion, these five formulas are important. What is this? Time of flight, horizontal range, maximum range R max, maximum height h or h max, and the equation of trajectory y is equal to x tan alpha and so on. So these five formulas you have to keep in mind when solving the problem of your projectile motion. So this is nothing but your projectile motion, then rectilinear motion and curvilinear motion, unit number 5. Samely, we have to see the unit number 6. Now, unit number 6 is based upon kinetics. Kinetics means F is equal to ma. We are not getting into anything like S, U, V, A, T here. We have to solve using the D'Alembert's principle, that is first part of the 6th unit. What is D'Alembert's principle? It is nothing but the reformation of second law of motion by the Newton. Summation of F is equal to m into a. Rather, summation of F minus ma, that is inertia force, that is their sum, is always equal to what? 0. This is nothing but your D'Alembert's principle. Samely, to use this principle, we have just rearranged the formula and this formula that we are getting. Now, what is D'Alembert's principle for rectangular motion or rectangular coordinates? This is particularly for curvilinear motion. Now, in curvilinear motion, we have to deal with first of all rectangular coordinates or Cartesian coordinates, we are cutting it as. So that is summation f is equal to what? M into x. Summation f by m into a. Similarly, normal and tangential, summation f is equal to m into n. So I have made it highlighted because this is somewhat important formula. Basically, we are getting more problems on these formulas. Then summation f is equal to m into at. Similarly, for radial and transverse. So this is the first part of unit number 6. What is the second part? Second part is work energy principle. So it is divided into work energy and work energy principle. What is work? Work can be done by four ways. Work done by the force. What is that? U is equal to force into displacement, isn't it? Then work done by the component of the force. That is a driving force. We are calling it as a driving force, and that driving force will be only having component in the direction of displacement. Similarly, work done by the gravity. Gravity means we are having that special case in the friction also. This particular is the driving force. And what is the driving force? If it is moving downward with the gravity, that is plus. If it is moving upward against the gravity, that is minus mg sine of theta into s. And last one is work done by the particular spring. What is that? U is equal to 1 half k x square. What is x? X is either elongation of the spring or compression of the spring. Getting it? So if the elongation is considered or there in the problem, then we have to take plus x. If the compression is there in the problem, you have to take minus x. Getting it? So what is energy? We are dealing with the two types of energy, potential energy and kinetic energy. MGH, that is a potential energy that is due to some, if the building is there and one tank is there, so it is having that potential energy due to its height. And what is this? If a ball is moving in certain direction, then it is having some velocity, so it is having a kinetic energy, that is 1 half mv square. Getting it? So what is work energy principle? That is whatever is work done should be equal to change in the energy. Means work and energy should be same. Work done is equal to change in kinetic energy. And that is nothing but the work energy principle. So similarly, we are dealing with the impulse momentum theorem also. So what is impulse momentum theorem? First of all, impulse. Impulse is the force applied, a large amount of force applied for very short time interval. Means a hammer is there and a nail is there. So we are hammering it with the force for very short time of interval. So this particular is nothing but your which kind of a force? Impulse force or impulsive force. Similarly, what is momentum? Momentum is mass into velocity. Bigger mass, bigger momentum. Bigger velocity, bigger momentum. That is mass into velocity. Similarly, as like work energy principle, what is the impulse momentum theorem? That is, impulse is always equal to what? Change in momentum. That is final momentum divided by minus initial momentum. Getting it? Now, along with this impulse momentum, we are having that impact and distribution. So there are some type of impact: direct impact, central impact, oblique impact. If the bodies are particularly having their impact line of impact in the same line, then it's a direct impact. Their CG is on the particular same line, then is a central impact. If they are not on the same line, this is oblique impact. Some type of impact are there: direct central impact, direct oblique impact, etc. etc. Getting it? So this is particular types of impact. Some theory part is there. It may possible that this theory part can be asked in the examination. Now, unit number, second type, that is from the impact and distribution, restitution. So we have to deal with coefficient of restitution. What is the coefficient of restitution? U2 minus U1 is equal to U1 minus U2. This is basically based on the momentum of the body. Now, this is, momentum before impact and after impact. So based on that, that formula is there. We can have that formula in this form also. 21 divided by 12, here is always B, here is always U. This can be your a trick if particularly mug out this formula. Other formula for coefficient of distribution is this under root of h2 upon h1. What is the h1? H1 is the dropping height, h2 is the bouncing height. And these formulas or conditions you have to use in the particular examples to solve. That is laws of conservation of energy. That should be done in the work energy principle. So energy neither be created nor be destroyed. It can be only transferred from one point to or one form to another form. That is always it remains same. E1 is equal to U2 is equal to E1 is equal to E2 is equal to E3 and so on. So what is that? For us, we are only dealing with the kinetic and potential energy. So this is kinetic energy plus potential energy at first point should be equal to kinetic and potential energy at second point. Getting it? And laws of conservation of momentum, that is also same. Initial momentum is equal to final momentum. So this is nothing but your initial and final momentum. Getting it? So this is how this theory is important while we are solving the problems. So if we are having good theory, then only you can solve the problems. Always remember that. So this important theory we have to deal with. Now we are going to deal with the problems. So one by one we'll see. Now see, if you are solving the question paper now. Unit number 5 and 6 means the problems will be from 5, 6, 5 or 6 and 7 or 8. 5 or 6 is from unit number 5. Now you have to deal with this. What is this? The sphere is fired downwards with the medium speed of this and experience the acceleration where it is in seconds. Determine the distance where it stops. So here acceleration is given. Deceleration means this is the constant acceleration. So this is uniform acceleration motion. This should be your first observation when you are solving the problem. It is falling under rectilinear motion, uniform acceleration motion. This is falling under projectile motion. So if you are dealing with this now, then this particular projectile motion is there. If projectile motion is there, projectile motion means you have to deal with those 5 formulas from this theory. So always remember, you have to first categorize the formulas according to the theory of the different units. So different units are divided into first types, then subtypes, then subtypes of subtypes. So we have to deal with that only. Getting it? Now here, a car starts from the rest and determine the acceleration of the car. Here, what is given in the problem with constant acceleration. So again, it is uniform acceleration motion for the rectilinear motion. So this is how you can deal with the formulas. Means we have to deal with that three formulas of Newton's law of motion. Getting it? Hmm? Now here also this is the formula. Getting vertically upward with this 30-meter height determine the time. So this is motion under gravity. So you can deal with this. Okay, this is the curve. Radius is given. As the radius is given, this is the curvilinear motion, and radius is given means we have to deal with rho. Rho means it is normal and tangential acceleration problem. Getting it? So this is how you can divide the problem into and apply the specific formulas from that particular type only. Getting it? So this is how you can deal with fifth unit. And in the sixth unit, this is also the same. Most problems are on the E, that is coefficient of distribution using impulse momentum theorem. What is the point here in the sixth unit? We have to use multiple particular what we can say formulas. Means you have to use law of conservation of momentum to find out the velocities. Then you have to use the coefficient of distribution formula to find the coefficient of distribution. Here the problem is very simple. See, this is based on E. Getting it? That formula is 2 upon H1. So this is the particular restitution problem. Here also, these all are similar. You have to use either energy, either impulse, work, momentum, and related formulas to that. Ready? So this is about sixth unit. So this is how you can solve the problems after rectifying it, which type is there, and this will be very easier for you to solve the problems on fifth and sixth unit. Thank you.